Yes? I'm sorry, can you guys... Shh, I can't hear. What? If you're in homeostasis, then you're already feeling normal. If you take a drug, and it throws you out of homeostasis, then you're not feeling normal. A lot of the addictive drugs that people take, they take the drug, it throws them out of homeostasis, and this makes them feel good, the way it throws them out of homeostasis. Now what happens with people who take a drug for a long, long time is that their body adjusts to the drug, so that way when they have the drug in their system, they're at homeostasis. And when they're at homeostasis with the drug in their system, this is when you're dependent. Because when you stop taking the drug, then it throws your body out of homeostasis and you need to regain this back. So at the point where people are dependent, yes, they are taking the drug to stay at a level of homeostasis.
So it's correct.
What?
We can also say that homeostasis is a correct answer.
For which one?
Number 4. Because I wrote
so he's saying that you could say that people experiencing homeostasis must take a drug in order to feel normal and avoid withdrawal symptoms. That is true for people who are dependent on the drug. However, for anyone who's not dependent on that drug, this is false. So the best answer, the answer that makes this correct all of the time, is dependence and not homeostasis. Does that make sense?
If there is a word must, then I think it's for the people who are already, we understand that for the people who are already dependent. If there isn't must, then if it's not like...
Okay, I'm experiencing homeostasis right now.
Yes.
Must I take amphetamine in order to feel normal?
It doesn't apply.
And avoid withdrawal. You say it doesn't apply to me, so that means that that's a wrong answer to that question for me. And for anyone else who's not dependent, which I would imagine is most of you guys. Yeah?
But also you want to avoid withdrawal.
Yeah, but right now I'm in homeostasis, I'm not, experiencing any withdrawal effect. Other than the caffeine, right? But I've had the caffeine this morning, so I'm not experiencing any withdrawal right now. If I didn't have the caffeine, I might have a headache right now. Okay? Alright, so this is drugs. Alright, so we're going to talk about 2 different classes of drugs. Most of the drugs we're going to talk about are psychoactive drugs. What is a drug? Wow, that's a great definition. A substance that alters the functioning of a body. I don't think I could have said that better myself. Substances that alter bodily functions. We're on the same wavelength. Okay, so what substances alter bodily functions? I mentioned one. Caffeine. Alcohol. Marijuana. Heroin. Not LCD. LCD is your computer monitor. LSD. Yes, you're right. Other things too. Oxygen. Oxygen is a drug. What? Is oxygen really a drug? How does it alter your bodily function?
Relaxing.
Oxygen relaxes you? I don't know how it relaxes. I guess, yeah, because when... If you don't have oxygen, what happens? We're all dependent on oxygen. If we don't have oxygen for 30 seconds to a couple minutes, we go through some very extreme withdrawal symptoms, right? I need to breathe. Not alcohol. Oxygen's a drug. Cookies! Cookies are a drug. Not just for Cookie Monster. Cookies are a drug for us too. How do cookies alter bodily function? You eat a cookie, what happens? You feel good, okay, maybe stress goes down, immune system function goes up, maybe, but there are other things too. Blood sugar, you eat a cookie, your blood sugar goes up, right? That has an effect on your bodily function. If you're feeling hungry, if you're going through withdrawal symptoms, not for cookies necessarily, but for food more generally, going through withdrawal, if you're really, really hungry, you get that food, it's nice stuff. How about psychoactive drugs? How do psychoactive drugs differ from every other type of drug? Yeah, the psychoactive drugs are substances that cross this blood-brain barrier, which is a barrier that keeps things that are harmful to your neurons out. And not all drugs are able to pass this blood-brain barrier. So those that can't, they're not psychoactive. The ones that do cross the blood-brain barrier and have a primary effect on your nervous system, we're going to call those psychoactive drugs. So which of these would be considered to be psychoactive drugs? Is alcohol?
Yes.
Yeah, its big effect on your performance is a cognitive effect that decreases memory, decreases awareness, lots of stuff. How about cookies?
No.
I would argue that cookies is not primarily a psychoactive drug. How about oxygen? I would again argue no. I think you guys are right. Even though our brain has this big response when we run out of oxygen, it's something that all of our cells need in order to do their metabolic thing. So alcohol, cocaine, yes. Cookies, oxygen, no. So how do drugs affect the central nervous system? Or how do psychoactive drugs affect the central nervous system? Sorry? Can you speak up? So it affects the functioning of the neuron? Yeah, that's exactly right. So drugs, they act on neurons. So what are neurons? This is a really easy question. Neurons are cells, that's right. Neurons are cells. So they have all the basic stuff that most cells have. They have a nucleus, they have DNA, they have mitochondria, they have ribosomes, all that good jazz. But in addition to all the normal stuff that you'd find in the soma or the cell body of any type of cell, they have some special parts too. The dendrites and the axons. What do the dendrites do? Yeah, they're receiving inputs from other neurons. So these dendrites are out there and they're waiting for signals from other neurons. And their job when they receive a signal is to pass that signal along. Yo, we got a signal, let's do something. So if enough of these dendrites are sending the signal, usually it's not just by stimulating one dendrite that will stimulate the neuron to fire its own action potential, but if we can stimulate a bunch of the dendrites, the stimulation will be so great that it will force the neuron to act. Imagine, like, the soma is like you, and something is happening, and all of your friends are telling you to do things. Oh, you should fight that guy. Yeah, fight that guy. And other people are saying, no, 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 don't fight that guy. So your decision whether or not to fight that guy, or to eat the cake, or to drink a shot of Raka is dependent somewhat on the signals that you're getting from the outside, right? So when you get enough of the signals to send your own message, then you do that, and that signal arises in the soma, and it travels down the axon. Axons can be really long. They can actually be more than 2 meters in length. So like giraffes have extremely long axons. My longest axons extend from about here down to my toe. So that's a good, what, 1.5 meters maybe? So,
but isn't that for every cell?
What?
The axon? For every cell.
Are they all that long for every cell?
I mean, for every neuron, there is an axon. And we cannot imagine that every neuron has that length of an axon.
Yeah, not every neuron has that length of an axon. There are some neurons that don't have axons. Some specialized neurons. You can learn more about those if you take biological psychology next year. But for the stereotypical neuron, yeah, most of them have axons to send messages. Because the neuron is basically an information processor. It's like a little computer. It's getting all these inputs, making a decision what to do, and then if it says, okay, we're going to send a signal, then it does that down through the axon. Okay, so at the end of the axon, what do we have? What are these little things at the end? Anyone get this? There are neurotransmitters. The structures are actually called N-terminals or N-bulbs or synaptic boutons. There's a bunch of different words for them. But there's this part of the axon that is connecting, basically, with the dendrite of another neuron. And there's a little gap between these two in most cases. So at the synapse, we have a lot of vesicles. They're like these little balls, and they're filled up with neurotransmitter. What's neurotransmitter? It's a chemical that allows a neuron to transmit a message to another neuron. It's very good. So these things are like bubbles filled with neurotransmitter. Imagine farting in a bathtub. I used to do this when I was young. My kids, you know, they're little, so they like to do this now. So they sit in the bathtub and they fart. And what happens? You have these bubbles, right? And inside the bubbles, there are not neurotransmitters, but there are chemical messengers, right? And they're all contained in this little bubble, like a vesicle. And when the bubble hits the surface, what happens? The bubble pops. And what happens to the chemical messengers inside of that bubble? It starts to diffuse, right? So the same type of thing is happening with the neurons. So when the axon sends an action potential at the synapse, what happens is that action potential signals these vesicles to fuse with the membrane. And by fusing, they release neurotransmitter into the synaptic cleft, into the synapse, where it then diffuses. And lots of things can happen as it diffuses. So what are some of the things that can happen as a neurotransmitter diffuses? So information is spreading, but if you say it's passed, it sort of indicates that there's a recipient, right? Are there recipients for these signals? Yeah, we have receptors. So we have receptors on this side that when they bind with the neurotransmitter, they're going to do something. We'll talk about what the something is that they do in a little bit. So we have receptors on this side. We also have some other things. We have these reuptake transporters. What is a reuptake transporter? What does it do? Yeah, what the reuptake does is it acts sort of like a vacuum cleaner, sucking neurotransmitter that's in here back into the cell. Why would this be a good thing to do?
Because it's keep running the affection, so keep decreasing the function.
So if we don't get this, if we don't get the neurotransmitter out of the synapse, it's going to continue to stimulate the postsynaptic receptor. Does that make sense? In which case, we may experience something, you know, a year ago, but the neurotransmitter is still there, still activating things. This would be a bad thing. So by sucking it up, it stops neurotransmitters from continually activating the postsynaptic responders. Additionally, it allows for the neurotransmitters to be recycled. Rather than having to continually make new neurotransmitter, you're able to suck some of it back up and reuse it later. There's some other things in there too. You have these little Pac-Man molecules, these deactivating enzymes. And what do the deactivating enzymes do? Yeah, they deactivate the neurotransmitters. They're basically going around breaking up the neurotransmitters, which means that the neurotransmitters won't be able to do their job once they're broken up. And again, this is important because it clears out the neurotransmitter, allowing us to send a new message, as opposed to having the same old message keep getting, you know, repeated. So we've got a couple other things. Autoreceptors. What are autoreceptors? These are receptors, just like receptors on the postsynaptic side. But auto means what? Like the Autobots.
Automatic.
It's automatic. Anything else? Like auto-regulation. It's something that's basically happening automatically by itself. So what's happening is that some of these neurotransmitters, when they get fused, it's not like you know, the bubble releases and then I say, aha, there's my receptor, I'm going to go right to her. Right? They're diffusing, so they're bumping into walls, not walls, but cell membranes. They're getting eaten up by these deactivating enzymes. Some of them get outside of the synaptic cloud and bind with autoreceptors. So what do the autoreceptors tell the neuron to do? Where to go? Can you be a little more specific? Imagine if we have a lot of neurotransmitter out here, what might that suggest? If we get a lot of neurotransmitter outside of the cleft, that suggests that potentially we're putting out too much. So the autoreception, when it gets messages, aha, I have a neurotransmitter, it sends signals to the cell to stop producing as much neurotransmitter or to stop releasing as much neurotransmitter. It alters the functioning of the cell so that way less neurotransmitter ends up in the cleft. Does that make sense? Now, there are other mechanisms too. We're just talking about a few of them, but they're important to have a basic understanding about if we're going to understand how drugs have their effects on the nervous system. So, alright, and synthetic enzymes basically put neurotransmitters together, and some other things package neurotransmitters in the vesicles and so on and so forth. Anyway, so I said that the neurotransmitters do something when they bind with the receptor, right, on the postsynaptic cell. So that the postsynaptic means when they bind with one of the receptors on the dendrites. So we have generally two types of effects. We have inhibition and excitation. You can imagine that the neurotransmitter is like a key. It's a molecule with a certain structure. And if you have the key for the right lock, what can you do? You can open that lock. If the key fits the lock in the right way, you can open the lock. And when you open the lock by activating the receptors, you have two different types of effects. One is an excitatory effect, and one is an inhibitory effect. So think back to the example that I gave just a minute ago. So you're there, and someone said like, Hi Vonson to you. You're an animal. And you're like, oh. And your friends, some of them are telling you like, go get him, go get him. And others are like, no man, just, forget about it. So which friends are trying to excite you? The ones saying, go get him, or the ones that are like, chill? The ones that are saying, go get him, right? This is an excitatory sort of response. So in terms of the neuron, it's not things saying, go get him, but there are certain ions, certain chemicals that come in that excite the neuron and make it more likely that the neuron will send its own signal. Whereas the inhibitory receptors, they allow different ions in, which make it less likely that that neuron is going to send its own message. So based on the balance and the strengths of these signals, the neuron makes a decision about what it's supposed to do. So if we excite the cell, we make it easier for it to send a signal. If we inhibit the cell, we make it harder to send a signal. And the effect depends on the receptor. Okay, so psychoactive drugs are having their effect, ultimately, inside the synapse. Either more neurotransmitter is going out there, we have new fake keys that also open the locks, or we're breaking things up more rapidly. So we have two general classes of psychoactive drugs. We have agonists and antagonists. So what does an agonistic drug do in terms of a single neurotransmitter? An agonistic drug is something that basically helps that neurotransmitter do its thing. You could make more of that neurotransmitter. If you have more of that neurotransmitter available, you can release more into the cell. Does that make sense? You could act as a master key. So for my office, I have a key and Madime has a key. Both of our keys work. They're a little bit different, but both of them work, right? So imagine that my key is the neurotransmitter. If we can duplicate the structure of that key synthetically, we might be able to open that lock as well. So something that would activate the receptors is going to be an agonist as well. They basically fight with the neurotransmitter. They fight on the same side. We can activate postsynaptic receptors. That's like Medine's key opening mylock. We can stimulate neurotransmitter release, basically like producing more farts in a bathtub. We can block autoreception. Blocking autoreception, how is that going to have an agonistic effect? You stop this self-regulation, which in this type of self-regulation specifically tends to tell the neuron to slow down, there's enough, right? So if we gag this autoreceptor that's saying slow down, it can say slow down, right? So we'll continue to keep putting out more. How about blocking deactivating enzymes? Why would this be an agonistic effect? Yeah, if we can block these Pac-Man deactivating enzymes, not really like Pac-Man, this is just an analogy. But if we can stop them from doing this, then the neurotransmitters aren't going to get broken up as quickly, and they'll have more time to diffuse and bump into the appropriate receptor. How about blocking reuptake? If we stop reuptake, what happens? So what does reuptake do again? Reuptake transporters? They collect the neurotransmitter out that are in the synapse and they bring them back into the cell, right? If we stop them, the neurotransmitter is not getting back in, so again it has more opportunities to diffuse and bind with the receptor. Increasing the availability of neurotransmitter parts. Do you guys like Turkey? Not the country, but Turkey. What is it called in Turkish?
Hindi.
Hindi. Do you guys like Hindi? No? Americans, stereotypically, we love Hindi. There's this big holiday that we have, Thanksgiving, in which people eat a lot of turkey. And after they eat the turkey, do you know what people do? They fall asleep. They watch sports and they fall asleep. Why do they fall asleep? Well, there's this particular neurotransmitter, serotonin, that regulates it's related to your circadian rhythm, and it's related to alertness, awareness, and your awakeness. And tryptophan, when you eat tryptophan, you basically make a lot more parts, serotonin parts, available. So this increases the serotonin output of your nervous system, which relaxes you and helps you to fall asleep after maybe you need dinner. All right, antagonists. What do the antagonists do? They don't fight with the neurotransmitter. They block the neurotransmitter, so they fight against the neurotransmitter. So, going back to this key analogy, right? So I have my key. I put it in my door, and it opens it up just fine. Now imagine that one of you came with your key, and you were able to stick it in the lock. Are you going to be able to open my door?
No.
Probably not. So what happens? Well, while your key is in my door, I can't stick my own key in there. Does that make sense? So if I'm a neurotransmitter diffusing and bumping into things and looking for the receptor, if there's another key in that lock, boom, and I bump into it, I can't bind with it and open it. Now some of these keys have such a perfect fit. It's like you take a key and you turn it and you break a key off in the lock. Have any of you done this? This really stinks. Because when you break the key off in the lock, you have to go get a locksmith to take care of this for you. It takes a long time to get it out. So some drugs that have been developed for use in war, like some gas agents, nerve agents, what they do is they end up binding with the receptor and not allowing the normal stimuli to do its thing, and it ends up basically killing people because they're unable to breathe or do some other regulatory processes. Okay, so we can block the receptors. We can block neurotransmitter release. If we're not releasing the neurotransmitter into the synapse, the message isn't going to get sent. We can activate autoreception. So maybe we have a key not for the receptor on the dendrite, but for the autoreceptor. And when we open that autoreceptor, what are we telling it? We're saying, hey, Slow down. Stop producing so much. Stop releasing so much. So we'll have less neurotransmitter in the vesicle. We can block synthetic enzymes. We can make it more difficult for the neurons to put the neurotransmitters together. We can block vesicles from filling. And there are lots and lots of other possibilities as well. So what should you know for the exam? If you know what reuptake does, if you know what autoreception does, if you know what deactivating enzymes do, you should have a pretty good idea about what would happen if we block reuptake or if we increase autoreception. So if you can learn those things, some of the other things I think are pretty easy. If you make more neurotransmitter parts available, duh, you'll have more of the neurotransmitter. But concentrate on the autoreception, the reuptake, yes, thank you, deactivating enzymes, and you go a long way. Okay. So why do people use and abuse psychoactive drugs? It feels good. Yeah, that's exactly right, man. Drugs are freaking awesome. So you take drugs and they say like you're high, right? You feel high, you feel great. You drink enough alcohol and the people that you previously thought were shivkin, is that right? Were ugly. Now they look good. These are effects that people enjoy. They increase confidence. They increase concentration, some of them. Almost all of the addictive drugs have an effect on dopamine. They're agonists for dopamine. Dopamine is a chemical that's associated with pleasure and reward. So when you feel good, you're activating some of the neurons that are producing dopamine. So drugs are really awesome. So why do we have all of these people like saying, don't do drugs? They're bad. I mean, who doesn't want to feel good? Who doesn't want to have better concentration? I like having better concentration. I'm drinking caffeine. Why aren't I taking methamphetamine or cocaine? It's because of the effects beyond these. It's not the short-term effects that are the bad things. It's the long-term effects that are the bad stuff. In addition to people like doing drugs because they're so great, a lot of people take drugs because their peers tell them to. Here, try this. You know, oh, check this out. It's really good stuff. So a lot of people, they start taking a drug because they've heard that it's good from their friends. So if they're so great, why are we told to avoid them? You already answered that. So let's talk about drugs, stress, and homeostasis. So drugs, they disrupt homeostasis. Your brain is in a state of homeostasis. I mean, things are always changing depending on the sights and the sounds and the smells that you're encountering. But generally speaking, it's in balance. And when we take drugs that have these huge dopamine effects that make people feel really, really good, there are these other effects related to cortisol and other things, and the drugs, by disrupting homeostasis, they produce stress. Remember, one of our definitions for stress was something that throws you out of homeostasis? So drugs disrupt the homeostasis. And by producing stress, what happens? With more stress, you get more cortisol, you get decreased immune system function, you get more infections, sick more often, take longer to heal. All right, so allostasis. What is allostasis? Allostasis is basically achieving stability. If you think about stasis being like this state, you're saying hello, or you're trying to say hello to homeostasis. So it's the process of achieving homeostasis. And what does allostasis lead to? It leads to tolerance, withdrawal, independence when it comes to psychoactive drugs. How? Why? Why does trying to re-achieve homeostasis after you take something like amphetamine or cocaine, how does this lead to tolerance, withdrawal, and dependence over extended periods of time?
The use is using drugs. Because the use is using drugs, it has affection, it has a withdrawal affection.
Okay, well, but why do we get the withdrawal effects? So, let's talk about amphetamine. Amphetamine is a really, really powerful stimulant, and it has a big effect on dopamine. And what it does, it doesn't block the uptake transporters, it actually reverses uptake transporters. So what type of an effect is that going to have? If we reverse the reuptake, what are we doing? Instead of bringing neurotransmitter into the cell, we're pumping it back out, right? So we're pumping, so we take amphetamine and we end up pumping dopamine into the cleft. So what's this going to do? Well, it's going to stimulate the postsynaptic dendrites, and people are going to go, ah, that feels great, but that's not all, right? So in addition to this, what other things are happening inside of that cleft? Normally we would have reuptake removing some of it, but that's not happening. In fact, it's pumping more out. What other things are going on? Well, the deactivating enzymes are doing their job, and they're deactivating dopamine. What else is going on? What was the other one? Autoreception. Yeah. So what's happening to the autoreceptors? We're basically dumping tons and tons of dopamine into the synapse. So how often are these autoreceptors being activated compared to normal? They're being affected a ton, right? Because you have all of this dopamine in the synapse, more and more keeps coming because you're not bringing it back up. Sure, the deactivating enzymes are doing their things, but what happens is a lot more of that goes and binds with the autoreceptors. And when they bind with the autoreceptors, what does that signal to the cell? It says what? Yo, I got something. Do something. What's the something you should do? Chill, slow down, stop putting out so much dopamine. There's way too much out here, right? So what does this do? It changes the cell's function to produce less dopamine. Does that make sense? Now imagine, you have less dopamine now. So if you want to take amphetamine again and feel that good again, how much do you need to take? Yeah, you need to take more of it. So we open up more, not open up, but so we reverse more of those reuptake transporters, right? And then the same thing happens again. You get the autoreception, yo dude, chill out, make less, right? So it ends up making less. So over time, what happens? Well, without the drug, you're not producing the same amount of dopamine that you did before, right? So what are you going to feel like? Dopamine usually makes you feel good, happy. If you don't have very much of this stuff, how are you going to feel? You're going to feel crappy, right? You're going to go through withdrawal, right? Because you have built up enough of a tolerance where you actually are dependent on the drug. Does that make sense? This is why drugs are so dangerous. If there was some way that we could, like take the drug, but then stop these long-term effects, it'd be great. Yeah, who wouldn't want to feel awesome? Yeah, I'll take a little cocaine before my kid has his birthday party, and I'll be extra happy. Right? The problem is that the long-term effects of these really has really devastating effects on your ability to be in homeostasis normally. So, what am I trying to say? When people go through, like Lindsay Lohan, she goes to a treatment center. This is horrible. They take you off the drugs. And you basically struggle and struggle and struggle for weeks and weeks until your body re-achieves the homeostasis without the drug. All right, good. So we've got that. Woo-hoo.
So the exact definition of tolerance is?
So, okay, tolerance. Someone give me a definition of tolerance. Yerem, can you give me a definition of tolerance? When you're tolerating a drug, you need to take more of it in order to feel the same way. So the first time that you take a drug, you don't have any tolerance. In the States, a lot of times freshman students end up going to the hospital with alcohol poisoning because they don't know how much alcohol they can have. And they see seniors drinking a lot of alcohol. And why can the seniors drink a lot of the alcohol? They built up a lot of tolerance, right? So the freshmen, they come in and they want to be like the seniors, so they try to drink a lot of the alcohol, and they don't have the tolerance, so they get too large of an effect, right? And they can end up dying because of this. So people that try the drug for the first time, they don't have the tolerance, so they get a much larger effect for a little bit. This is why drug dealers, they often will give out drugs for free. Why would you give a drug away for free? Well, because if I give you the drug for free, you'll see how good it is. You'll get this positive, oh man. And you'll say, that was awesome. I want to do that again. So you come back, yeah, here's another one for free. Oh man. Okay, how much? Right? And you'll spend money for it. And then you'll develop a tolerance, which means you'll buy more and you'll pay more. Right? So we start with peer pressure. What's the difference between use and abuse? Can anyone tell me?
Use is always better.
So abuse is a particular type of use. It's use that's, I guess, not done with like a doctor's prescription. It's using drugs in a way that can be detrimental in the long term. Yeah?
Recreation.
Yeah, it would be using drugs for recreation as opposed to for some medical purpose. So there are some stimulants, like Ritalin, which is very similar to cocaine, but people take it with a prescription and it actually helps them because they already have a neurotransmitter imbalance. And by taking the Ritalin, it restores the homeostasis. So we have use, which leads to tolerance. When you have enough tolerance, you become dependent. And when you take that drug away, since you're now dependent on the drug to maintain the homeostasis, you experience withdrawal. A brief note on the hypnosis. So we talked a little bit about state theories, social roles, and the cognitive behavioral theories. And my favorite of those three is the cognitive behavioral. It says basically that it's your expectations that are changing the way that you behave, right? Based on your expectations. And we've seen this with the placebos. People think they're going to get better. It ends up having an effect, even though it really shouldn't. In terms of drugs, there have been some interesting things that people have done. Like, I think it's at Harvard or Princeton, some students, they set up a drinking party, but they used non-alcoholic beer. And what happened at this party?
You got drunk?
Yeah, everyone got drunk. They're all drinking this non-alcoholic beer, which is like drinking, you know, orange juice. Orange juice has alcohol in it, not very much. Same thing with the non-alcoholic beer. But the people are expecting to have these feelings of euphoria, and they're expecting to lose their inhibitions. So they do it not because of anything that's there, but because of their expectations. They basically hypnotize themselves. All right, I'll see you guys on Wednesday when we are going to talk about human uniqueness.